All right, in this video, we're going to take a look at determining phase shifts of a sine and cosine function. So in trigonometry, phase shifts are the periodic functions' version of horizontal shifts. So we saw vertical shifts in the last video. In this video, we're looking at horizontal, or as we call them in trigonometry, phase shifts. The reason they're called something different is primarily because of that periodic nature, that repetitive nature of the graphs of sine and cosine functions. So for sine and cosine functions, phase shifts are typically going to resemble the following. Something like y equals sine of bx minus c, or it could be sine of bx plus c. And also y equals cosine of bx minus c, or bx plus c. So notice in these examples that we're going to be adding or subtracting a number inside of our sine and cosine function. So when you add or subtract a number inside of a function, that indicates a horizontal shift, or as we call them in trigonometry, phase shifts. So to find the value of a phase shift, just set what you're taking the sine or cosine of equal to 0 and solve. So if it's bx minus c, set it equal to solve, or set it equal to 0 and solve it. If it's bx plus c, do the same. And what's happening is this is going to be the value, this value that you get when you solve for x in this equation is how far any x-intercepts of your graph are going to shift. So positive answers end up shifting those x-intercepts to the right, and negative answers for this equation up here are going to shift the x-intercepts to the left. So example 4, determine the phase shift of each of the following. Don't forget to include the indication, the direction of shifting. So for part A, we have sine of x minus pi over 6. If we set x minus pi over 6 equal to 0 and solve it, we get x equals pi over 6. So in other words, we took our original sine graph and shifted every point pi over 6 units to the right. So let's see a visualization of that. So here we have a dashed sine function, just a parent sine of x graph. And then for this part, we have x minus pi over 6. So if we take a look at our x-intercepts, here was our original x-intercept. We can use the origin in this case. And now we have an x-intercept of pi over 6 units. It took this x-intercept and shifted it to the right pi over 6 units. So, and it's true for all of them. So even at negative pi, and negative 5 pi over 6, this is a shift to the right pi over 6 units. So I tend to try to find the easier points to analyze. All right, part B, we have y equals the cosine of x plus 3 pi over 4. So setting x plus 3 pi over 4 equal to 0 and solving it, we get x equals negative 3 pi over 4. So this one, because it's a negative answer for x, it's shifting our original cosine graph 3 pi over 4 radians to the left because of the negative. So looking at that one, here we have in a dashed red line the cosine of x, and now we have in purple the cosine of x plus 3 pi over 4. So looking at over here, we have pi over 2 as an x-intercept. Notice this pi over 2 is on the down wave for this original cosine graph. So we have to go over on the purple graph for the x-intercept of a down wave. And here we get 7 pi over 4. So if we look at the difference between 7 pi over 4 and pi over 2, that is a difference of 3 pi over 4. Part C, we have y equals the sine of 2x plus pi over 2. So this time we just have a coefficient in front of x, which is going to be a horizontal compression by a factor of 2. So set 2x plus pi over 2 equal to 0. Subtract pi over 2 from both sides. We get 2x equals negative pi over 2. And then either divide both sides by 2 or multiply both sides by a half. I'd probably do the latter. Multiplying both sides by a half gives us x equals negative pi over 4. So because it's negative, we are shifting our original graph pi over 4 units to the left. So taking a look at that one, it is a sine, I believe. Yes, a sine wave. So here's our sine wave. And here we have, make sure that's, 2x plus pi over 2. Okay. So we said that it is a shift pi over 4 units to the left. So if we look at this origin here, this is on the downside going to the left. So on the downside of this graph in red, we have an x-intercept at negative pi over 4. So again, notice it took this 0 at 0, 0 in this case and shifted it pi over 4 units to the left. Finally, part D, y equals cosine of 3x minus 3 pi over 2. If we set 3x minus 3 pi over 2 equal to 0 and solve it, add 3 pi over 2 to both sides, we get 3x equals 3 pi over 2. And then either dividing both sides by 3, or as I would do, multiply both sides by 1/3. 3 pi over 2 times 1/3 gives us pi over 2, and it is positive. So this one is a shift of our cosine graph of pi over 2 units to the right. So looking at that one, here's our cosine graph again, and example 4D here, it said is a shift of pi over 2 units, shifting pi over 2 units to the right. So, all right, so that about does it for this video. Thanks for watching, and I'll see you next.